So hi guys, welcome back to the channel. We are going to start a new series on NLP specialization with the booming of the AI revolution, mainly in the text-based NLP section. So we are going to start a new series, and the first this will be the first video. It will be a raw video. We don't have a script or anything. We are going to deep dive into the very basics of NLP, and we will go to the very advanced topics like the transformers and all in the upcoming videos. So bear with me, and hopefully we will get to learn a lot of stuff, and we are going to have deep dive on the maths behind the cut. We are going to have a deep dive into the mathematics behind the NLP and the AI. Along with that, we will also have hands-on coding, the maybe small stuff on the coding side, but again, those will be the very fundamentals that will help you to build whatever you will build in the future. So yeah, for this particular video, for the video number 1, we are going to have this topic: introduction to supervised ML and sentiment analysis. So mainly these are the questions that we are going to answer, and we are going to learn all these steps. What is sentiment analysis and its application? We will learn the basics like what are sentiment analysis, where we will use those. Then we will have the supervised ML frameworks and overview. After that, the complete pipeline from feature to predictions, output, cost, and then updates. We are not going to deep dive in this particular video, but in the upcoming videos we will deep dive into each of these topic and see how what are the data we are dealing with and how they are transforming over from one step to the another. And later on we will have coding sessions on this particular steps. Then again we will have binary classification for positive and negative tweets. Why do we need binary classifications, and how does it help us for our sentiment analysis on those particular tweets, like from positive and negative. Then we will also see real world examples and use cases. So I'm going to show you my notes as of now. So mainly the architecture of this videos will be like this. I have my notes on the readme files, .md files, markdown files. So we will mainly use this as the main source material, and we will explain all this. But again, apart from this, we will also have like hands-on maths derivation and all those drawings in the OneNote that I will show you in the videos that are coming in our timelines. And along with that, we will also have like hands-on coding, maybe on the Jupyter notebook or like in the VS Code or whatever. We will see that in the future. So yeah, let's look at our first video. So it's on mainly on the supervised ML and sentiment analysis. So what is sentiment analysis? Sentiment analysis is the fundamental NLP task. Like we can start with this in order to learn more about the NLP. So what does it determine? It determines the emotional tone or the opinion expressed in a text. For example, if we see a text like I love this course, so we can note that it is a positive tweet, right? Someone is showing his love towards the tweet and all. And if someone says like I don't like this course, we are not getting enough knowledge from this course, that will be a negative tweet. So this is our main task as of now, to classify the tweets as either positive or negative. So this week focus will be mainly on the binary classifier, to classify the tweets as either positive or negative using logistic regression. So we will be using, let me just zoom in a bit. Okay, I think it should be enough. So our main task is to use logistic regression to determine whether a tweet is positive or negative. So as of now, also in the upcoming videos we will deep dive more into the logistic regression part, so that you guys can have a more like a deep intuition of what logistic regression is. I think you already know that if you have taken like another courses on like deep learning and all. But let's say if you need a revision, we can do that too. So what is sentiment analysis? Sentiment analysis is the computational study of opinions, sentiments, and emotions expressed in text. I think in the earlier days of the AI, maybe some people came up with the idea like, why not use the AI for get the to get the sentiment of like what are the what does this text really mean? Either they are positive or negative. Also, they have a lot of use cases. For example, in social media monitoring, someone gave a post right in Facebook or like in Twitter or like in Instagram and all. So if we have a social media monitoring system using this sentiment analysis to know whether we are a brand is getting positive feedbacks, a product is getting positive feedbacks, or an event is getting positive feedbacks or negative feedbacks, we can it will be a huge use case for those big brands and all. Again, apart from that, we also can get like the customer feedback from the reviews and all, like from the for Amazon or like eBay or like similar kind of e-commerce sites. They can have analyze their reviews in a very quick manner if they have a sentiment analysis on their system. Apart from that, I think people can also do like market research and all before launching the products. It would be really helpful for those brands or like product developers, if they know like what kind of market they are going to sell their products. And also like political analysis too, like understanding people's opinion and like whether they are fit for the maybe the political rally or like whatever. So yeah, let's try to understand what is supervised machine learning. So mainly in the supervised machine learning, we have these inputs and the outputs, right? We want to get our system to predict the outputs that are close enough to the labels that we have in place. So let me just show you maybe with this diagram or like this drawing. So for example, we have this input right on the left hand side, the input or the features. For example, we have tweet number 1 as I love this course, and we have the outputs, or we call them as labels. That means the real output that we have with us for this input. So for this I love the course, we have the output as positive, and for the second one, I hate this course, we have the output as negative. We can also have the output positive as 1 and the output negative as 0. We are using these numbers in order to show the output levels that we have over here. Positive means 1, negative means 0. We have this kind of systems. So mainly we will train our ML model to have predict this kind of tweets as either positive or negative. Since we will have the original output labels with us, we will know that how much close the model is to the original output or labels, and we will try to improve the models over time so that the model can predict either positive or negative that is close enough to the original label that we have with us. So we will feed all this input and input 1 2 3 4 5 all this into this ML, and we will then train it to get the outputs outputs that is predicted, and then we will compare that with the labels, the original outputs that we have with us. So mainly in the supervised machine learning, we have the inputs and the outputs, and we know the outputs that the inputs should predict. So after the model predicts some amount of data, either positive or negative, we will compare that with the original labels, and after that we will revert back to the model and update the parameters, for example the weights, either W or like the bias, and we will update those such that the next prediction output will be close enough to the original level. So don't worry if you are not getting the supervised machine learning as of now, since this is just the beginning, and in the upcoming videos we will deep dive more into this particular topic. So maybe in those videos you will get an idea of more like what is supervised learning and how do they actually work and all. So yeah, in this particular mermaid diagram also you can see that we have these features on the left, then again we have the predictions, then again the prediction give us an output, that is the y hat. This is the predicted output from the model, and then we have the original levels in the green box as y, and then we have the cost, that is we will compare the output y hat predicted one versus the level y, that is the original level that we have, and then we will update the parameters such that we decrease the cost, that is we will make the model more efficient such that its predicted output will be close enough to the level y, as much close as possible. So we will deep dive more into this particular one in the upcoming videos, but as of now this is the diagram that depicts like what we are we will learn in the upcoming videos and all. So yeah, input features x, then parameters theta, then prediction function, that is the ml model and all, then again output y hat, that is our predicted sentiment, probability or class, and also it will give us like the prediction of like how much percentage of probability do we have that the tweet is positive, and how much probability we have for that the tweet is negative. And then we will have the cost functions, and we will try to decrease the loss and all. Then we will update the parameters. We will see all this in a greater detail in the upcoming videos. So again we have the sentiment analysis complete pipeline. So let us see a glimpse of like what we are going to build in the upcoming videos. So concrete example is I am happy because I am learning NLP. Then we have tweets like this: I am happy because I am learning NLP and all those. Then we will extract the features. How we will extract the features and all, that is also in the upcoming videos. So after that we have the training logistic regression. Then we will classify, and it will classify as either positive or negative, and in this case it is a positive one, so it is having the positive as 1. Then again sentiment classification rule, the positive sentiment will be labeled as 1 and the negative one as labeled as 0. This is a binary classification. Binary means either positive or negative. Task where logistic regression assigns each tweet as either positive or negative, one of the two. The 3 steps process will be feature extraction, that is represent the text I am happy because I am learning NLP as a numerical feature x, because we can't work with the text as of now. We are in the very beginning of the NLP course and we are learning from the basics, right? So what we used to do in the past, so we are going to learn that. So in the past we are going to convert this text into numbers so that we can train on this. Then again the train logistic regression using training data to learn parameters that minimize prediction errors that I told you earlier. Then we have the classification, apply the train model to predict sentiment, 1 for positive, 0 for negative. Yeah, that's all. And this is one of the another diagram that we have over here, the 3 steps process. First one is the feature extraction, then training logistic regression, minimize cost functions, then learn optimal parameters theta, and then we will classify the new tweets. Again we have the mathematical representations and all. Input we have the x, and then function as f of theta x, we get the y hat, that is predicted function with parameters theta, and then the output y hat will be either it will be 0 or 1, predicted sentiment class. Then again training, while training we will just minimize, we will try to minimize the cost with respect to the y hat and y by updating the theta. So again if you're thinking of like why do we use logistic regression for sentiment analysis, it's mainly it because it signs in this kind of problems we have the binary classification in hand, and it's a great way to use this in order to solve this problem, perfect for positive and negative sentiment tasks. Then we have the probabilistic output. As I said earlier, for the class 1 it will give us like we have 70% chance that this belongs to class 1. Then again 20% 30% chance that it belongs to class B, and the sum of all this will be 100%, 70% for class 1 and 30% for class 2, that is either 0 or 1. We have that kind of output, probabilistic output. Then again, interpretability, easy to understand which feature contributes to which, and all those, and efficiency and baseline performance, often performs surprisingly well on text classification tasks. So we are going to use this. The core challenge is mainly to convert it from the text to the numbers. So we'll see that in the upcoming videos, how we are going to convert the input that we have as the text tweets into numerical representation, and how are we going to use those. So this process is mainly called feature extraction or text vectorization. So as of now, I think we will be using the traditional one, and in the future we will use the modern one, modern approaches. For example, as of now, we will use handcrafted features, bag of words models, frequency based, then simple but interpretable. Then in the later one, in the upcoming videos, we will use learned representation, then word embeddings and what's not, and again context aware, complex but again powerful. So yeah, and the real world applications are simply like social media monitoring, then customer feedback analysis, market research, and political analysis, and all those. So yeah, I think that's it for this video, and in the upcoming videos we will be learning about vocabulary and feature extraction. So that will be an interesting video. So I hope that you learned a lot from this video, and in the upcoming videos we will be diving deep into this topic, video number 2. And I hope you like this video. If you like this video, please don't forget to give it a thumbs up and hit the subscribe button for more upcoming videos like this. So yeah, bye till then.